All right, so let's start with number one on this handout, review for final handout. Just going over some problems we've been over in the past. Maybe it's been a few days since we've done some of these, so reviewing is a good thing, huh? Number one, we've got universal set 1 through 12. And A is 4, 6, 7, and 8. And B is 3, 4, 5, 7, 9, and 10. Number A, we want to do A, first of all, A intersection B complement. All right, so yeah, again, that's intersection, right? And what does intersection mean? What they have, think intersection of streets, that's what they have in common, right? So I'm looking for what they have in common. A intersect, now what is this set? B, what's that mean? A little mark there. Complement, right? And the complement means what's not in there. So B complement, I'll come over here. B complement, B's got 3, 4, 5, 7, 9, and 10. So B complement would have, compare that to the universal set, B complement would have 1 and 2, and 6, 8, 11, and 12 would be B complement. With me on that? So I want to look at A intersection these. So what do these have in common? Well, they've got 6 in common and 8. That's what I see. 6 and 8 are in both of them. Is that okay? All right, then I flip that and do A union B complement. What does union mean? That's where you combine them both, right? You put everything in set A with everything in B complement. So that would be, well, if I go in order, put 1 and 2, I got 4, I got 6, 7, 8, 11, and 12, don't I? So yeah, remember, union means put both of them together. Everything in set A with everything in set B complement, or whatever the sets are. Okay? B. Simple enough looking one. B minus A in sets, how do we do that? Well, the way I suggested was, this says B take away A. So I'm going to start with B. B is this one, 3, 4, 5, 7, 9, and 10. And then take away any elements that are in A. So A has 4, 6, but 6 is not in there, so it doesn't get taken out, obviously. And then 7 is in A, so it gets taken out. And then 9 and 10 are not in A, so I'm taking out 4 and 7. So that's going to leave me with 3, 5, 9, and 10. That's B, take away A. Yeah, there's various sundry formulas to recall here. C, I want to know the subset, number of subsets of B. That's a formula, isn't it? What's the formula? 2 to the nth power, it's a power of 2. Which power of 2 is it in this case? What's the power here? Power is the number of elements in that set. So B has how many elements? 1, 2, 3, 6 elements. So the number of subsets of B would be 2 to the 6, which is 2 times 2, 2 6 times, not 12 or 36. It's 2 times 2 times, punch it on your calculator, whatever, it's 64. 64, if I were to write out all the subsets of B, there would be 64 of them. And remember, one thing I'd highlight there, I didn't put it on this, but if I were to write these out, the subsets, 64, remember I have different sizes. I have 1 element subsets, 3 would be a subset, 4 would be a subset, 5 would be a, what else? Well, I could do 3, 4, 2 in a subset at a time, 4, 5, 3, 5, 3, 7. I don't want to do that for 64, but there are different sizes of them. I might ask you about that, but yeah, they range up from one size of one element to, well, even set B is a subset of itself, isn't it? So you can have one element subsets, you can have 6 element subsets, 5 element subsets. So remember that. Now the other thing I didn't ask either, but what about proper subsets? How does that relate to this? Remember? It's one less, yeah. The number of proper subsets would be 63, one less. It's always one less. Okay, which comes up on D there. True or false? 6, 8 is this of A. What is this? Remember, there's 2 symbols there. You got subset and you got proper subset. Which one is this? Which one is that? One of them has a line under it. Remember? Well, our little trick was, think of that as a backwards P. That's proper subset, isn't it? This is subset, just regular subset. All right, so is 6, 8 a proper subset of A? Remember, a proper subset, a subset can be the same size, but a proper subset has to be smaller in size. So is 6, 8 a proper subset of A? Is it a subset and is it smaller in size? And I think so, yeah. 4, 6 would be a subset of A, and it's smaller, so it's a proper subset. That one's true. E, draw a Venn diagram. Okay. Yeah, so we did some Venn diagrams. What are we talking about there? We're talking about there the little rectangle with the circles, interlocking circles, like the Olympic rings, partially. Now, if I'm doing this one, I'm just going to place the elements in there. So where would, let's just start with 1. Where would 1 go? Well, 1 is not in A, nor is it in B, so it would go on the outside of the circles. 2 is not in either one either, so 2 would go outside. What about 3? 3 is over there in B, but it's not in A, so it would go in this little moon shape right here. Because if I put it there, it'd be an A also. What about 4? Where's 4 go? Well, 4 is in both of them, so it goes in the middle. 5 is only in B, so it goes over here with 3. 6 is in only A, it's not in B. 7's in the middle, it's in both of them. 8 is in A, but it's not in B, so it'd go over with 6. 9, where did it go? 9 is in B, but not in A, so it would go over here with 3 and 5. 10 is the same way. And then we've also got 11 and 12. So neither in A or B, so it would go over here somewhere out here. All right, so Venn diagrams, did various things with Venn diagrams. Now, F goes right along there with E. That's what I intend. All right, how many elements are in, number of elements in A and B? Remember, we talked about the and the or in sets. We talked about it in several places, but here in sets, remember, to be in the and, what does and mean in sets? And means intersection. And means the intersection. So I'm looking for the number of elements in the intersection here. Well, in the Venn diagram, how many elements you got in the intersection? Where's the intersection here? It's right in the middle. So I've got 2 elements. How many are in A or B? Well, that's a different word there. Or means the other, doesn't it? That means union. So which of these elements, tell me which elements are in A or B? The union. Well, the union is everything in A combined with everything in B. And remember, we shaded. So if I shaded the union, I would shade everything here. So that would include the 6, the 8, the 3, the 5, the 9, and the 10, and even the 4 and the 7 again, because that would be in the union. Union is everything in A. These are in A, they're in B, so they're in the union. So how many have I got? 1, 2, 3, 4, 5, 6, 7, 8. 8. Is this okay? Number 1. Questions or concerns about number 1? Will it be this like this way on the test? There might be some slight variations, but if you know the basics, yeah, questions will be very similar to the test questions. Some of these are very much like test questions, so I would say yes. Okay. All right. Number 2. What are we doing on 2? Oh, 2, we start the logic. Write the inverse and contrapositive of the statement. Yeah, we talked about inverse, converse, and contrapositive of an if-then statement. If I study, then the test is easy. Is the statement here. Yeah, it's good advice too, but the inverse and contrapositive. We talked about the inverse and converse and contrapositive, but here I specifically state inverse and contrapositive. Remember, different things happen for the different ones. On the inverse, think in. What do you do for the inverse? Negate. In for negate, okay? Yeah, the inverse negates. The converse flips. So I'm going to negate these. If I don't study, then the test is not easy. Right? Test is not easy. That's the inverse. What about the contrapositive? What does the contrapositive do? Flips and negates. It does both. Flip and negate it. So I'm going to take if. So I'm going to flip this over to the if part. If the and negate it. If the test is not easy, then flip the if part to be the then part, then I didn't study. Okay. Number 3, construct a truth table for not P or Q and not Q. Okay. So the truth table, the little table here. Over here we put our P's and Q's. And how does P's and Q's work? Well, there's 4 of them. You got true, true. Usually start that first. Then we do true, false. And then false, true. And then false, false. Do that for our side over here. And then we do our various things for this. What does this mean? Squiggly P. Not P, yeah. Opposite of P. So here's P, true, true, false, false. I'm going to go false, false, true, true underneath it. Then for Q, well, Q is just the copy of the Q, true, false, true, false. And then there's not Q, so I'm going to do the opposite of the Q, so it'd be false, true, false, true. All right, then I'm going to combine them. Of course, I'm going to start with what first? Parentheses first. All right, which is this one? The V. In logic, the V stands for OR. And how does OR work as far as the truth value is concerned? For OR to be true, do both of them have to be true? No. Or only one of them has to be true to be true. False or true, that's true. False or false, that's false. One of them has to be true for it to be true. True or true, that's true. You got one true, and then true or false, that's true as well. Mark those out. Because now I want to take this with that and those together. How does and work? Same way as or? Not quite. For and to be true, what? Both of them have to be true. For and to be true, both have to be true. So true and false, that's false. False and true, that's false. True and false, that's false. True and true, finally, we get one that is true. And so the final result, the rest of these don't matter. It's just the final result. False, 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 true. Remember that? Just like yesterday, right? All right, number 4. True table 4. Not P, arrow Q. All right, so it's still a P and Q statement, so it's P's and Q's. Over here we got true, 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 false, false, true, false, and false. All right. Again, we got not P, so I'm going to do the opposite of the P, so it'll be false, false, true, true. And then Q is true, false, true, false. Arrow. If this is an if-then, how does it work? A little bit trickier, right? There's only one time the arrow is false, and which is it? Huh? No, if they're both true, it's true. It's true, arrow, false is false. That's the only false in the bunch. Only time the arrow is false. If it's T, arrow, F. If it's reversed, F, arrow, T, that's true. If it's T, arrow, T, that's true. If it's F, arrow, F, it's true. That's the only time it's false. All right, so what have I got here? I've got false, arrow, true. True or false? That would be true because it's T, arrow, F. This is F, arrow, T. F, arrow, F. That's the real tricky one. Both of them are false, but on arrow, that's true. Okay. T, arrow, T, that's true. T, arrow, F, that one's the false. T, 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 F. All right. Number 5, which is also in the logic realm. What do we got? Write the negation. Okay. All right. Well, start us off with a fun one. Some classes are harder than this one. Guess what I mean. Maybe not at the moment, but anyway, some classes are harder. How do I negate? Remember the quantifiers like some and none and all negate a little bit differently. You know, sometimes you can just put the word not. This one, if you just try to put the word not, that's not going to negate it. Some are not harder is not a negation. Remember, some, the negation of it, you have to go with no or none. The negation of some is no or none. No classes are harder. Some classes are not harder is not a negation. And so vice versa. No, you would negate it with some. All is a little bit easier. You can just do not all. But remember those quantifiers. So that's some negates with no. All negates with not all. So forth. All right. B is a little bit easier. I will study. Kind of got a theme going here. I will study and I will pass. How to negate that? Well, the and statements, the or statements are a bit easier. To negate this, well, I would negate I will study, I will not study. I negate I will pass, I will not pass. And what else do I do? What about the and? To negate it, to negate an and statement, you got to change it to an or statement. To negate an and statement, you got to change it to. You negate the parts, but then you change the and or works the same way. If that would be an or, I would have changed it to and. To negate them, you change them over to the other. Now, what about the if-then? If I study, then I pass. Well, the negation there, a little bit trickier. Remember, if you've got if P then Q, the negation of that is, remember? Actually, you only negate one of the things. You only negate Q. You get P and not Q. You change it. You only negate the Q. And then the other thing is it if then now? No. What kind of statement? It's an and statement. So we're going to get rid of if then altogether and replace it by and. And then the other thing is I'm not going to negate the first part, I study, but I am going to negate the second part, the Q. I do not pass. That is the negation of an if-then statement. I study and I do not pass. Remember? We did those. They were fun back then, too. All right.